NASA's 3D Printed Habitat Centennial Challenge. Now, as you can see by the construction where we are, we were actually inside of Caterpillar's demonstration and learning facility just outside of Peoria, Illinois. Now, as you might recall, this is actually not our first time inside of this gorgeous facility. NASA 360 was here 2 years ago when teams had the opportunity to build smaller components. But this year and today, the competition is bigger and better. Actually, they're building 15 feet tall habitats that could potentially be used on future missions to the moon and also to Mars. Now, guys, this is going to be an incredible competition, so let us know first off where you're watching from, and if you have any questions at all about the competition and about the different challenges, please write them below and we will let you know the answers. We have the NASA 360 team on standby. Now, as I said, we have a lot to cover today, but before we do that, let's take a quick look at what happened earlier this week with the competition.
So we're here at the 3D Printing Habitat Challenge competition. I am more than excited. There was a lot of things that have to come together.
Monday and Tuesday were dedicated entirely to setup. We had an 18-wheeler driving here, loaded with all our equipment, and we had to take it off with the help of Caterpillar, connect everything together. Basically all the things that make our system work.
There's a lot of things to make sure they work together. There's a lot of equipment.
We're currently in the middle of day 2, so we're halfway there. We really need all 30 hours to print this thing. The quality of the print is at or exceeding my expectations for what it would have been.
What I'm really excited about is when we finish, this is going to be the very first building that is totally constructed and enclosed by 3D printing. We hope everything goes well from this point forward because this is so huge.
I'm nervous, yeah, but it's not a bad nervous. The goal is to finish the structure because
we are all together developing a technology that advances the way we think about constructing buildings on Earth. Nothing gets done without multiple people coming together.
It's often counterintuitive that space research actually improves Earth, but it's seen time and time again. Whether you spin off a technology or like we're trying to do spin in a technology.
And this is a technology that we're all developing together.
Challenge. So let's come this way. I'm going to introduce you to someone. So joining me actually on this adventure is my guest co-host Taylor from NASA. Taylor, this is going to be an incredible competition.
It is. Hi guys, how are you doing?
What's that?
Oh, I said hi guys, how's everybody doing?
Oh yeah, so guys, as a good reminder, make sure you guys write down first off where you guys are coming from. And again, if you're just tuning in, if you have any questions for the NASA 360 team or about the challenge, we'll be on standby to get those answers for you. So guys, we're going to hear exactly from you guys. So let's talk a little about this challenge and why this is such an important Centennial Challenge. What do you think?
Okay, so today's challenge is focusing on the technologies that we're going to need to build a habitat off of our planet. And they will be using both recycled materials and the resources available around them to make a habitat sustainable for the astronauts that will someday be living on the moon and Mars. All of this has to be done autonomously, so hands off of the printers once they are turned on. And in this final round of the 3D Printed Habitat Challenge, teams are building a 1/3 scale habitat using equipment and materials that they have designed themselves.
You know, so I mean, we're seeing a lot of hard work that's gone into this particular challenge. I mean, weeks, actually even years, because the competition hasn't been going on for that long. So let's also talk about what viewers can also expect from today's challenge. What do you think?
So in today's challenge, the teams have their final 10 hours of print available allotted to them. So today they will each be finishing up their models. So by 6 o'clock today, their scales will be done and their time will be up, and then tomorrow we will be getting into the stress testing.
Wow, so it's so great because you think the things interesting about it is, first off, the teams have different feedstock as well, so that in itself will show that the strategy is going to be very different.
Right.
So I'm looking forward to talking with both teams. We're also going to be talking to some astronauts, talking to some judges. So we have a lot in store for this particular challenge.
Right.
Now, here's the thing. So I'm going to go and talk with one of the teams.
Okay.
So you will talk to someone about more details about the challenge.
Okay. All right, so as Caleb said, we are here in Peoria, Illinois at Caterpillar's Demonstration and Learning Facility. Now, I would like to introduce everybody to the program manager of Centennial Challenges, Miss Monty Roman. Monty, how's it going?
Oh, it's going awesome. Thank you.
Okay, well, we have some questions for you today. So, what is NASA's Centennial Challenge program all about?
The NASA Centennial Challenge program is about inviting the public to come and see and develop technologies that we can use for future NASA missions.
So, why are these challenges important to NASA's mission of returning to the moon and exploring Mars?
So we are super interested in the technologies that the public have, because of course we have lots of very, very smart scientists and engineers at NASA and around the contractors, but there's so many other technologies that people like the ones you are going to meet today have that they're using for other Earth applications, and we're interested in listening to technologies that we might have not thought about in the past.
So, with this challenge, who are we trying to engage?
We're trying to engage everybody. So there's not an age limit. There's nobody that cannot participate on our challenges. So anybody that has a technology that can help solve a NASA gap that we open as part of a challenge is invited to participate.
So, why do you think that it's important to have this be as inclusive as possible?
It is important because right now I keep hearing over and over again, like, I never thought about doing it that way. So these people do not have a constraint that we have of schedule, budgets, sometimes about how we do things, you know. These people completely do not have any of those barriers. So they're free thinkers, and the technologies, some of the technologies that we see here come out of really not having that, you know, what cannot be done mentality to start with.
Great. So, what does NASA primarily hope to gain from this particular challenge?
Well, there's many things, but three important things right now. So number one is, and what the first one that we're going to see very, very, very soon is Earth applications. So there's a team here that will be building these full size already on Earth. As a sustainable system that can be used now to build habitats, you know, inexpensive habitats. So we can see that. The second thing we're going to see out of this is the development of a network of people that think alike. So the network that is happening, the people that are meeting each other today, what's going to happen with them is that eventually they stay together and they're going to form a network of people that could potentially push the technologies to where we need it for vertical construction, which is something that is not, there's not a lot of investment there right now. And the third thing, and the most awesome one for us, would be that in the future we might see things like this on the surface of the moon or Mars.
Right. So, what do you think is the main benefit that each team will take away from this participation?
Well, as I said, number one will be the networking, not only with themselves, you know, the other teams, but with Caterpillar, with the venture capital, with the allied organization, Bradley University. The networking period is very important to them because they can, from here, they can get new ideas, they can get maybe infusion of money, just get their name out there and their and get what they're doing out there so people know what they're doing. So that will be for them something important. And also they will get ideas of how to make things better. So right now they're out of the laboratory, so this is amazing that they're doing things real time on a dirt environment. So a lot of things can be happening. So this is a demonstration of something a lot of people never thought will happen. So that's one of the most important things that is happening. It was on paper, now it's for real.
Can you take the picture?
So, why does NASA offer prize money for this competition?
We want to incentivize the people to, so there's many ways to incentivize. Prize is one, money is one, and sometimes, you know, they have to have some kind of return on investment on this, what they have put together here. There's also a lot of other incentives that for them to come. So price is one, money is one, but there's several other ones too.
Great. Well, thank you so much, Monty. And guys, there you have it. Through NASA's Centennial Challenge program, we can engage the public, involving people who might not otherwise be involved in this mission and taking us back to the nation's space program. Caleb, I'm going to send it back to you.
Hey, I'm sorry, before we go, there's just so many cool things here at the Caterpillar facility. Can we get a quick photo of in this area? This is just like the coolest thing. It'll only take a second, I promise. I'm sorry. This is like the coolest thing, guys. Okay. Here we go. We're gonna do the selfie. We're gonna do the selfie style. Here we go. Let's get in there. Ready? Oh yes, there it is. Great interview. All right. All right, so guys, come with me this way. So, so as you know, so this is the last phase of the challenge. The team's been working really hard. Let's go underneath here. Let me take you this way. All right. So now for our next interview, we have is David from AI Space Factory. AI Space Factory. David, thank you so much for being with us.
You're welcome. My pleasure.
So first off, let us know what is your role as part of the team.
Well, I co-founded the company, and I guess I'm the sort of chief architect overseeing the team. My role here at the competition is limited. I'm leaving it up to my guys to figure out how to build this.
Now, why did you guys decide to get involved in this particular challenge?
Well, you know, as I was watching this technology develop, I see that the real applications for this are on Earth. You know, for me, it's space-driven technology. We're designing for Mars, but it's a way that we can build for the future here on Earth. What is unique about the way that we are printing this is the material. The material is recyclable and renewable. It's basalt and biopolymer, and that biopolymer is made from corn, from sugarcane, you know, things that we can grow. So it's about a future of building, which is harvesting materials. And at the end of its life cycle, we can actually compost the structure and return it to the earth. You know, grow the next generation of materials. If we think about how buildings are built today, they're hugely energy intensive. This is pointing to a future where we can grow our buildings, and it starts today. So if you ask me what's in it for me, I'm doing this for my kids. I have a son, Leo, he's 12, Elena's 14. They've been following what we're doing. You know, they were part of the group of kids that had a protest about a month ago. Remember that? Where, you know, the children of the world decided to stand up and say no to climate change, and that we have to do things differently. I've been an architect for more than 20 years. I built some of the tallest towers in the world, and I know how much concrete and steel goes into those buildings, how much energy it takes to build, and it's not sustainable in the long term. You know. And you know, today is where we take a stand and decide to do something different. We need to build in a different way. That begins today. So for me, you know, Marcia is what we call our Mars habitat. It's like a message in a bottle, right? You know, it's about, you know, going for the Mars, going for the moon, but it's also about finding a way to build here on Earth.
So you also mentioned as well that the practical applications, you know, what's really big with NASA you know, are the spin-offs. So what are some of the on-Earth applications that you're looking to accomplish with this new technology?
Yeah, so we are being very ambitious. So what we're going to do, and I understand NASA will actually crush this thing to destruction tomorrow, and that actually gave us the idea for what to do next, which is to pick up the pieces of this, recycle and reprint it. Oh yeah, so we are going to print our first Earth habitat, which we call Terra.
Wait. You're telling me you're actually going to do this now? Where's that happening? What location?
So we are going to, we have 2 sites outside of New York City, and we are going to start construction this summer. So we're going to pick up the pieces of Marcia. So we are going to pick up the pieces of Marcia and use it to reprint Terra. So Terra is our Earth habitat. We are going to start construction this summer. It's a proof of concept about a building which is renewable and recyclable. It's pointing the way towards a future of construction that doesn't involve concrete and doesn't involve steel.
Wow. So what we're looking at here is this is a 1/3 model. So how big will the full-scale model be, or your anticipations for the on-site locations?
So for the real Terra, it's going to be substantially bigger than this. We actually want people to live in it. We will be making it available to the public as an Airbnb. Yeah, so and we're going to start this as a crowdfunding campaign later this month, so hope you all look for news for that, and the early backers will be the first people to stay in Terra. So it's going to be like a piece of space technology that's literally reborn from this material because we're recycling this to print Terra, and people who are interested in space or people who are interested in sustainable construction can stay there. They can actually live in it, actually experience it, stay in overnight, understand what it is when we're trying to talk about space-driven technology that's going to solve some major challenges here on this planet.
So, you know, it's been a very long week, month, years, really. What have been some of the challenges that you have faced when building this structure?
Well, everything that you see in front of you was built ground up. And amazingly, you would think we've been doing this for years, but the team never touched a robot until about 7 months ago. Okay, so a lot of us are, our backgrounds are as architects, but we share this passion about technology and using architecture to kind of make positive impact. So you can see the robot that was all sort of like, hacked together. It's got that sort of sort of jerry-rigged vibe to it. We built this forklift that you see, behind the print. That's actually going to lift the robot up higher today. So we just, address the problems one at a time as they come along. That's what we do. Is just roll with the punches and figure it out.
Now, if you're just tuning in, you're watching NASA 360. We were at the Caterpillar demonstration and learning facility for NASA's 3D printed Habitat Centennial Challenge. Now, the teams are building 2 different structures that are going to be, I believe, 15 feet in max total to be used in future missions to the moon and to Mars. And right now we're here with the CEO of AI Space Factory, just talking more about the competition, the challenge. Now, what we're looking at here, we noticed here on the top is that you have Virginia Tech decal on there. So what are some of the partnerships that you came together with for this competition?
Yeah, so no company can do this alone. And if we think about a moon or a Mars mission or even building on this Earth, it's going to take a lot of people, right? So we have Autodesk and Caterpillar here. Autodesk really gave us so much support. They loaned us the robot. Virginia Tech and their researchers are helping us with the material. So that's their hopper that you see. So the material gets fed into that, and then we're printing with it. So this next phase, I think, in Earth construction, space construction, is going to take a lot of different minds working together. Big companies, big universities, but also nimble startups like AI Space Factory.
That is incredible. David, CEO of AI Space Factory, thank you so much for your time.
Thank you. Thank you very much. Pleased to be here.
All right, guys, so, man, this is so incredible. There's so many great things that are happening for this particular challenge. Now, if you're just tuning in again, we are at NASA's 3D Printed Habitat Centennial Challenge inside of Caterpillar's demonstration and learning facility. Now, what's really interesting, what we just learned from the first team is that they're actually going to be crushing this particular structure and then recycling it to use it again for another structure in New York for an Airbnb, and it's going to be called Terrace. Look for that. It's going to be incredible. But right now, let's talk with Taylor to find out who she has next. Taylor.
Hey guys, I'm here with Penn State's team. Do you want to introduce yourself?
Hi, my name is Jose Duarte, and a professor at Penn State.
Awesome. So what has been going on with your team this week?
Well, a lot of work. So we are printing these large structures for the first time. We printed parts of the structure, so we were curious to see how well we would do. I think we were doing good.
So can you give me a little bit of detail of what's happened today?
So today, when we started, we had a problem with one of the sensors, which was turned off, and we didn't realize that immediately. So we had a bit of a problem at the beginning, but then we solved the problem. We are already printing again.
Awesome. So what has been the biggest challenge that you guys have faced thus far in this phase of the competition?
Well, we are developing the technology, but the technology is not there quite yet, so there are lots of issues that need to be solved. So the challenge was to print a structure this large with the current state of the technology. And I think, we are doing good, and I believe in the future of this technology. I think, buildings that will actually be done this way in the future.
Cool. So can you tell us a little bit about your design and what makes it unique from the other teams?
Okay. So we have different streams of research going on. They merge for us to design this shelter. The shape, stems from a number of factors. So we are dealing with design, materials, and the printing system at the same time. So this is the structure that we can best print with the current state of the technology. So you see the angle at which we are printing is the maximum angle at which we can print without the structure collapsing. And so we are doing that to make the roof at the same time creates a very nice interior environment.
So you guys were actually part of this construction challenge here in the same arena 2 years ago. What's the most important thing that you learned from your past experience, and how has your design changed?
Well, at that time, we didn't have the full design yet. We changed the materials, so this material is much easier to work with. It prints smoothly, which is very good. The other material was setting too fast. which is good to hold the shape, but not very good when it's extruding because it was clogging the machine too often. But this is a beautiful material, so it's working very well.
So give us a little sneak preview. What can we expect to see from your team at the end of today?
So we hope to complete the structure, so the cones will be finished and close the structure entirely. And it's going to be very strong, so I'm actually curious to see how well they will manage to crush the structure. We did some tests in the lab, and it was very, very strong.
So each of these two teams has a unique strategy for building their habitat. Each robot arm is different. The feedstock going into each printer is a special blend of recycled materials and resources that very closely mimic the regolith or the surface material that would be found on the moon or Mars. So Caleb, I'm going to take it back to you.
Thanks, Taylor. Now, although there are only 2 teams here printing today, this challenge has been going on actually since 2015. So there's been a lot of people, a lot of iterations, a lot of just exploration and development that's been part of this challenge. So this is what NASA's calling a celebration of the achievements of all the teams who participated from the beginning. So right now, come along with me and we're going to have a conversation with one of those teams, one of the first teams. Joining me now is Melody. Melody, pleasure to meet you.
Yes, hi.
Hi, so let's talk about first off, who was your team and what did you guys do?
So I am a co-founder and the team leader for Search Plus APIS Core. Search Plus is short for Space Exploration Architecture. We were one of the first Phase 1 winners for the 3D printed habitat competition, the Centennial Challenges that is now continued to Phase 3, which is what we're now in. And what we do is we design and we engineer habitats for long-term human survival in outer space.
Wow, so we know that there are multiple phases and levels of this competition. So let's talk about a little bit about Phase 1 and Phase 2.
Right, so Phase 1 was exclusively a design competition that was asking teams to develop proposals for long-term human missions to Mars. For that phase of the competition, we won for a proposal called Mars Ice House, which was a habitat for which we introduced water as a radiation shield for a crew of 4 on a mission to Mars. And Phase 2, as compared to Phase 1, was exclusively a construction prototyping competition where teams were asked to perform concrete compression cylinders tests, 3-point flexural beam tests, and then a smaller dome structure was 3D printed at a head-to-head event, very similar to this one, but in much smaller scale.
And again, guys, if you guys are just tuning into what we're doing here, we are at NASA's 3D Printed Habitat Centennial Challenge inside of Caterpillar's demonstration and learning facility just outside of gorgeous Peoria, Illinois. Now, there have been multiple teams, multiple iterations, multiple exploration as part of this particular challenge. And we are speaking now with Melody from Search Plus for this particular competition. Again, guys, let us know if you have any questions or comments about the challenge, and we will make sure that our NASA 360 team is on standby to answer those questions for you. So there are actually 3 phases to this particular challenge. We just went over Phase 1 and Phase 2. So tell us about Phase 3.
Right, so Phase 3, which is the current phase that we're in right now, is both a design and construction prototyping challenge. So teams are asked not only to submit proposals for future Martian habitats, but to also demonstrate through construction prototyping what material and deposition system they would be introducing for 3D printing those habitats.
You know, and what's interesting about this challenge is that there's a lot of collaboration. So for your team, what things have you personally gained in terms of collaboration or just growth in terms of this challenge?
We learn so much by collaborating with others, whether they be consultants, subject matter experts, technical consultants. Even in the relationship between Search Plus and APIS Core, there was a mutually beneficial collaboration going on in the way that we shared ideas and pushed the project forward, both in terms of design and in terms of construction prototyping and technology development.
You know, it's also interesting with these particular challenges, Centennial Challenges as a whole, is that it doesn't just benefit the challenge. There are what NASA calls the spin-offs. So can you talk a little bit about the spin-offs that could possibly be involved with this particular challenge?
Right. The best example of a spin-off is that in phase 1, following the first prize win for Mars Icehouse, we were very fortunate to be connected with the group at NASA Langley and the Game Changing Development Program with our PI, Kevin Kempton, and we were able to develop our concept further into what's now known as the Mars Ice Home. And we've been planning for a subscale demo of that concept and have been doing material science testing with Sheila Theobald, who's an expert at NASA Langley in material studies, and we've really been able to continue that collaboration till today.
So with your phase, you guys were doing the design aspect of it. So what were some of the challenges for the design aspect? And then also looking forward, what are some of the challenges, potential challenges for the teams today?
Some of the design challenges that we encountered just had to do with synthesizing all of the considerations and requirements and constraints for what it will mean to satisfy and deliver a comfortable but also forward-thinking habitat for a crew of 4 for 1 year. So we really consider things from a human factors perspective, what will be meeting the needs of the people who want to be living long-term, not just to survive in outer space, but to really thrive and to really, and celebrate their presence on a new planet. So there are many, many factors and considerations to take into account, not only technical ones and engineering challenges, but ones that really have to do with human factors and celebrating a human presence on another planet.
So one more question, I'll let you get back to the competition, to enjoying it. What has been the most exciting thing that you've seen for this challenge?
I think the great thing about the head-to-head event is that we have 2 different material systems that are going up against one another, a cementitious concrete mix and then a PLA and basalt-based mix. I'm really glad it's not 2 of the same materials going up against one another. I think that there's a lot to be gleaned by the testing and the analysis that's going to go forward here. So this is a really exciting event to witness. Yeah.
Cool. Melody, thank you so much for your time.
Absolutely. Thank you so much.
Now, guys, the construction industry is on the verge of revolutionizing the way we build, from space habitats on Earth to additive construction and 3D printing will all play a crucial role in the plans. And no one knows construction better than Caterpillar, the world's leading manufacturer of construction and mining equipment. Let's check in with Taylor to see who she has.
Thanks, Caleb. So guys, as you can see here, we are surrounded by a sea of black and yellow, and I am here with Dan Henderson, the Director of Innovation and Emerging Technologies at Caterpillar. Dan, how you doing?
Good, thank you.
Good. So we've got a couple questions for you today. So can you tell us a little bit about the venue that we're in today?
So this is our Edwards Sales and Demonstration area. We typically bring customers and dealers and other people here for training or exposure to our products and equipment. And we think it makes an excellent venue to host a competition like the Centennial Challenge.
Awesome. So why was Caterpillar initially interested in becoming a sponsor for NASA's Centennial Challenge program?
We've had a history of working with NASA for more than 15 years in a variety of challenges, and we found that these are good ways for us to help advance where the technology can go in order to give us some practical insight into where the industry may go behind it. Customer interest, new technologies, emerging technologies, this is a great way for us to get an early look at that.
So how does Caterpillar directly benefit from this specific phase of the challenge?
So in this one, as you can see, looking around, they're building actual miniature scale versions of these habitats. We have customers, direct customers, who are interested in using this kind of 3D concrete printing technology in practical applications like earth moving. We want to be a part of understanding how that technology is unfolding so we can see how our customers are going to begin to demand it from us and what role we may play in the future in helping support them with that.
Awesome. And how does Caterpillar use 3D printing? I know you guys have a lot of different projects going on. So what are some of the things that you use it for the most?
We've actually been users of 3D printing for more than 20 years, and in the last 5 or 6 years have really expanded that more into all types, metal printing, rubber printing, plastic printing, as well as sand printing in our foundries, so we can do low-cost manufacturing of even individual piece parts, and we use it in that capacity.
But what do you think has been the most exciting 3D printed project that you've had so far?
Actually, this sand printing one that I mentioned in our foundry has been our most exciting. It allows us to do single individual castings of parts at very low cost and high velocity, and once we'd commissioned that, it's been very effective in helping us solve our customers' problems more quickly.
Nice. And how do you think that the construction industry is going to change in the next several years?
Boy, that's a great question. We know that these sort of technologies are going to make their way into vertical construction, especially in areas where they need rapid construction, in remote areas where it's hard to get materials. And we think that this will be an aspect that our customers are going to grow with their leverage of it, and we want to be able to be involved in that as that happens.
And why do you think that this is important to change going forward as we start looking to build on places other than our home planet?
You have to be able to work with the materials that you have locally in a situation like that. It's very expensive to move material from Earth or anywhere else, or really from a place like America to some remote area. And so being able to just send the equipment and then work with local material to do the construction that's required is going to be an important capability.
Great. And besides off-world habitats, how do you see this technology directly benefiting people on Earth?
Well, there is interest in people like the Army Corps of Engineers and others in being able to create low-cost, very rapid construction of things like barrack huts, or in response to disasters and things like that. These kinds of technologies could potentially be a solution to that.
Awesome. Well, thank you so much for joining us today, Dan. I think Caleb is back with one of our teams, so let's check in with him.
Hey, thanks, Taylor. And if you're just tuning in, we are live for NASA's 3D Printed Habitat Challenge inside of Caterpillar's demonstration and learning facility just outside of Peoria, Illinois. So right now I'm here with team lead Shadi from Penn State. Shadi, thanks for being with us. So first of all, let's talk about your team. So who do you have on your team? What are some of their roles?
We have 6 professors on our team, and 3 of us are here now. We have been leading basically the students who are on in our departments and under our direction. So we have 2 people from the Department of Architecture, 2 professors from the Department of Architecture, 2 from Civil and Environmental Engineering. Those 2 are not here today. And Sven Millen, who is the head of engineering design in terms of professors. Then the students, Ken over there, he's studying civil engineering, so he's right now controlling the pump. Who else do we have? Nate.
I know it's hard to see.
Yeah, I know. Nate is over there now overseeing the program, a robot program. And what else? Those are the students now on the scene. Wow. Yeah.
So there's so many things happening right now. So let's go over here. I'm going to see this right here. You have some notes here. What exactly is this? What are we looking at with this information here?
So we 3D printed beams of a certain size that we were required to print, and we brought them with us. Our material is concrete, and for reinforcement, we tested 2 different materials. One was steel, the other was a fiber reinforcement polymer. Steel behaves better under tension, so we tested that today. In general, concrete is a stronger material under compression and not as much in tensile.
Now, I noticed too that your structure is obviously different than what the other team is doing. Why did you choose this shape for the structure?
The shape of the structure is very much directly related on what we're able to print right now, given the technologies that we are developing. So, for example, how much the material can be supported without any form work and also without any internal support. So that's a major element in our decision making. Generally, we're looking at the constraints that we have, and we're turning them into opportunities to further develop our technology. In general, the competition has been wonderful for us because it is speeding up our research in many different areas in terms of materials, in terms of development of systems, and development of the relationship between the systems and the materials and architecture. Because every time you have a new technology, the architecture has to adjust and be designed in relation to what is available for construction.
You know, of course, guys, we're live on multiple platforms, and actually, we just received a question from Nathan Smith. Nathan would like to know, how do you install electrical systems?
I am not the right person to ask, but so we have people from electrical engineering who study basically what the needs are of the robot, of the pump, of the silos, and in relation to all those, they make decisions.
What are some of the problems with printing in a low air pressure? Does it affect the curing process?
Absolutely. You mean out not on Earth? Right. So one of our team members actually has sent to the space station samples of dry materials that were mixed with water on the space station. And they compared it live actually to the way that this was happening on Earth. Yes, so water behaves differently when you're outside of Earth's atmosphere.
Well, Shadi, how do I say Shadi from Team Penn State, thank you so much for your time.
You're welcome.
All right, I'll just get back to it. Guys, this competition is heating up. And if you have not heard yet, we are actually in Peoria, Illinois for the NASA's 3D Printed Habitat Challenge. Now, this challenge has been happening since 2005. There's been so many different iterations of it. There's a lot of things going on. There are actually more than just 2 teams here, but only 2 teams are left for the final phase, phase 3 of this challenge. So let's chat back in with Taylor with AI Space Factory.
Hey guys, we are here with Team AI Space Factory. This is Chris. Chris, how's it going?
It's going well.
And do you mind telling us a little bit about your team?
Yes, so we have 1 mechanical engineer that's working on the team, 1 team lead, and I'm the robotics specialist on the team. And then there's a couple others that have been helping out as well.
So what are the main areas of expertise within this team?
So the engineering obviously deals with the calculations and things like that. The team lead and myself were involved in the design process and more of the architectural side of it. And then there's also the robotics side of it, programming the robot, figuring out the print paths, and then basically all of us, all hands on deck during the print, figuring out how to solve all the problems that come up.
Great. So how do you feel personally about being part of a NASA Centennial Challenge?
I think it's great. I mean, we've been staring at this thing in the computer screen for like months now, so to be able to see it taking shape in front of our eyes and then the other teams coming up at the same time, it's really exciting.
Okay, so we have a question from Mario on Facebook. Mario wants to know what materials you're using for your print today.
So our material is a hybrid. It's 60% PLA, which is a normal plastic that a lot of 3D printers use, and then it's 40% basalt fiber. And basalt is a rock that exists on Mars, and it gives the material a lot of tensile strength as well. So it's those 2, and then the red color comes from a little bit of pigment that we added to get it to look like Mars.
Nice, that's a good touch. So what do you hope to accomplish through this challenge?
Well, there's lots of lessons learned with this print. We've never printed anything this big before, and we have plans afterwards to move on to other structures similar to this scale with the same machine. So it's very good that we've gotten this far.
So we've heard a little bit about Terra through your Instagram page. Can you tell us a little bit about that?
Sure. So Martia is the Martian structure that we're building, and Terra is the first structure that we'll build on Earth, essentially. And we hope to make it an Airbnb experience that people can rent out and occupy the structure themselves after it's built.
So what are some of the big benefits that you've seen from being involved in this challenge so far?
The main one is just being at the forefront of a budding field, essentially. It's very small, the amount of people that are actually doing these things. So getting to see the other team go, which is a great thing. And getting to know this field, which is growing, and it's going to only get bigger as time goes on.
Yeah, that's exciting. So what can we expect to see from your team tomorrow?
Well, ideally, we pass all the tests, and there's no catastrophic failures or anything like that, which we don't anticipate, but that's what we're hoping.
All right, well, thank you so much, Chris.
Thank you, Taylor. Now, you guys know this is a very exciting time in space exploration. And if you didn't know, it's been 50 years since the Apollo missions, and now NASA is moving forward to go back to the moon and to stay there. So quite naturally, it seems obvious to talk to someone who's actually been to space as we talk about the 3D Printed Habitat Challenge. Joining me is astronaut Don. Is that how I say it?
Don Thomas, yeah.
Don Thomas.
Astronaut.
Excellent. So now the first question I have to ask you is, how can I get one of these really cool jumpsuits? I mean, it just looks so good.
Yeah, these come out of the Navy. You know, they're flight suits that the Navy wears, and this is what the astronauts wear when we're flying our T-38 jets. It's a flame retardant material. It's comfortable, but we don't fly this in space. We've got other clothes for that.
Well, thank you for that. So you've been an astronaut for how long?
I was an astronaut for 17 years, from 1990 to 2007.
Okay, so let's talk a little bit about just your career history, what you've done, what you're a part of.
Yeah, I joined NASA in 1988. I was an engineer working at the Johnson Space Center on the Space Shuttle program. And then 3 years later, I became an astronaut. That was a lifelong dream of mine. And I went on to fly a total of 4 missions, 3 aboard shuttle missions aboard Space Shuttle Columbia and 1 aboard Space Shuttle Discovery. I've spent 44 days up in space and went around the Earth 692 times during those missions. It was really an incredible experience.
Wow. In your opinion, what are some of the challenges that the next set of astronauts might be facing?
Our next astronauts' challenge is longer, farther missions, you know, so going to the moon, going to asteroids, visiting Mars, you know, that we're building these habitats for. So the challenge is going to be, you know, even further removed from Earth. When you go to Mars, you look back at Earth, it's a tiny blue star. That's a tough psychological thing. That's Earth over there, that little star. You know, you're going to be far away. Communications will be a little more challenging. You know, it could be a time delay of 15 minutes. I say, hello, Mars, and it could take a half an hour before the signal gets there and comes back and says, hello, Earth.
And we know that NASA has ambitions to go back to the moon and then also to Mars. So with this particular challenge, you know, we're building habitats. So how would this particular challenge help with that mission?
You know, these are autonomous systems to build habitats there. So when you go, if we're going to build a lunar base, you know, that's the reason for building a lunar base is to try to learn all you can in preparation for missions to Mars. So these habitats will be perfect. I mean, when we get to Mars, we want to have a way to protect the astronauts. You have to have an enclosed environment for them. It's got to be totally sealed. It has to help protect from micrometeorites. You have to protect from radiation in space, you know, on the surface of Mars there. And what we're learning to do here today is just really incredible, because this is the technology we need developed to build habitats on Mars.
And if you guys are just tuning in, we are live at Peoria's demonstration and learning facility for NASA's 3D Printed Habitat Challenge. I'm here with former astronaut Don Thomas, just talking about the competition and the different challenges. So we know with this challenge, we're dealing with sustainable housing. So why is sustainable housing so important in space?
You know, we have limited supplies, resources up there. Everything that we need in space, we got to bring along with us. You know, we need water, we need oxygen, food, everything you can think of. There are no, you know, convenience stores, no grocery stores, nothing like that up there. So we have to take everything with us, and we've got to be sustainable. You want to be smart in how you use things. We're learning that today on the International Space Station, for example. We take urine from the astronauts and
Urine. Okay.
We take urine and they purify it into drinking water. That's part of sustainability. We don't have unlimited water. We don't have a tap up there. And that's just one of the examples. It sounds very disgusting, naturally, but this is what we have to do when we're going out into deep space. We're far from Earth, limited resources, and we got to learn how to be sustainable in the, you know, the highest sense of the term.
I got one more question for you, and I'll let you go. What has been the most exciting thing that you've seen over the past couple of days?
I'm going to say 2 things, okay? The first is these incredible habitats, to see what we're doing. I get a tingling feeling. I get a shiver down my spine because I see, hey, we're learning how to build these habitats. It's real. The second thing that is really exciting are the young students that have been coming through. Yesterday we had 150 middle school kids. Today it's 200 high school kids. They come and they see the technology. They see what we're doing, because they are the generation of astronauts going to Mars. We call them the Mars generation. And to see their excitement. So I talk to them about what it's like in space, and I say, hey, we're building the new Space Launch System rocket to send astronauts to the moon and Mars. And they come out here and they see, wow, you guys are building habitats. I tell them we're building the rockets today. We're learning to build habitats. We need our astronauts ready. So the message to them is, we need you. You know, you're a part of this program. You're the next generation scientists, astronauts, engineers. So that is really exciting to see that spark in their eye, the twinkle in their eye. It's the same one I had 50 years ago.
Wow. Don Thomas, thank you so much for your time.
You're very welcome.
All right. All righty. Wow. And this has been an incredible day so far. Taylor, how was it for you over there?
It's been so exciting today, guys. We've met so many interesting folks and crew members today.
I mean, I just was talking to astronaut Don Thomas, and he was just talking about the importance of sustainability. So, for example, they actually even filter their own urine up there, but they do it so well. It was also interesting, too, is that just the different materials that each team is using, I just think just fascinating.
It is. And that, the urine testing, that's actually something that our program manager, Monty, was involved with before the challenge. So she was kind of at the forefront of all of that. And seeing her be able to get involved with more adventurous things like this challenge is so exciting for us.
Wow, and what's just really interesting, too, is I find that there's so many different collaborations that have come out of this. Even just talking with AI Space Factory, they work with multiple people, including Virginia Tech, to help with the, I believe it's called the, I'm not sure what it's called, but it actually holds the feed of the material. What's also very interesting as well is that when I was talking to Shadi from Penn State, and she was just saying just the different calculations they had to use, and the fact that the way that their material expands. So there's just so many different factors that with Centennial Challenges, NASA can use the technology for these challenges, that's why they always have them, to expand and go further and farther. And the next challenge, they're looking to go back to the moon, which is huge, back to the moon. It's been 50 years since the last Apollo missions. So we're looking to go to the moon, and then next we're going all the way to the red planet.
Yep, we're going to rendezvous to Mars, and it's very important to keep in mind on the sustainability topic that all of this material and all this technology is going to be implemented on the Earth as well. So it is dual purpose.
Well, so guys, thank you for tuning in with us. But we'll be back live at 4 p.m. Eastern here for NASA's 3D Printed Habitat Challenge. I'm Caleb Kinchlow.
And I'm Taylor Goodwin.
And we'll see you guys a little later.